Hey man, stop! Where are you going? Are you going writing some Python code? No, just joking. But seriously, stay with me because in this video we are gonna uncover one of the most powerful features in Rust, and this is how to match patterns. I know what you're thinking. Many Rust haters think that coding in Rust is simply impractical. But if you stay with me and you keep watching this video, I'm gonna show you how actually when you use the match pattern, it's actually smooth and a fun experience. Match is a powerful control flow construct that allows you to compare a value against a series of patterns and conditionally execute some code. And guys, pattern is simply a broad term because a pattern can be literals, variables, wildcards, a combination of them, so everything that you can think of. And why this works? Guys, the power of match comes from the expressiveness of patterns and exhaustive checks made by the compiler. But I know that I'm boring you with all of this yapping, so let's write some actual code. So, before diving into the actual syntax, let's just explain the use case of today. Let's pretend that we are playing Pokemon, a Pokemon game, and we want to know something about our Pokemon moves. So, in particular, we can have a struct that represents our Pokemon like this. So, Pokemon will have a name field, which will be a string, a level, of course, and then a series of moves, which is just a vector that points to a series of string literals. Okay, cool. So, in our main block, we can start creating a Pokemon, and since I am an OG Pokemon fan, I'm gonna go with Blastoise. So, let Poke equals Pokemon with name Blastoise, a level of 77, and then a series of moves, which are my favorites in this case: Hydro Pump, School Bash, Ice Beam, and Rest. Okay, cool. And now I'm gonna encode this series of 4 moves as an enum type. And if you don't know what enum is, I recommend that you watch my previous video on enums, because I'm really sad nobody watched that, so if you want you can just check it out, and you will understand later why I'm using an enum here. So I'm simply repeating an enum move with all the 4 moves that I gave to my Blastoise. Okay, cool. And now the real meat of the video. I'm gonna implement a method on the struct Pokemon, and this method is move description. So, of course I have to add some reference to the lifetimes because I'm using a vector of moves which contain reference to string literals. So this is just how Rust goes. And then we have the function move description, which takes a self-reference, which we don't actually use here, and then a move, which is an enum move, and then we have our dir match pattern. So how this works: we have the match keyword, then the value that we want to compare, which in this case is the parameter of the function move description, and then we have a series of arms. These guys are called match arms. We have the expression, we have the pattern, which in this case is move Hydro Pump, or move School Bash, move Ice Beam, move Rest. So the expression here is our move equal to one of them? If so, we are gonna execute this expression. So we have on the left of the arrow the pattern, and on the right the expression. In this case they are simple expression because we are just gonna print out the description of our move. So for example, if we pass move semicolon semicolon rest to our function, so if our move parameter is rest, the code will actually print out the user lives for 2 turns to fully restore HP and heal any status problem. So guys, I think that this is pretty straightforward, but you can see here the power of the match pattern, because we are not gonna write any if-else block. It's simply, what's the value that we have to compare? Okay, what's the result of the pattern? Cool. And then we have the selected expression. So this is actually pretty straightforward. So to put it simply, an arm has two parts, a pattern and an expression, which is some code to execute. and arms, as you can see, are separated by commas. The value is compared against each arm pattern in order, and when a match is found, the corresponding expression gets computed and the match execution block terminates. Since an arm contains an expression, curly brackets are allowed also, but in this case we are just print some code out, so it's just a line of code and we don't need curly brackets. So now in the main block I can call this method on our Pokemon, so we call poke.moveDescription of move ice-beam. And if you compile this, it's gonna print out the description of ice-beam, which is the foe is struck with an ice beam, it may freeze the foe solid. And actually, ice beam is one of my favorite moves. It's really cool. Now, one important thing that you have to understand about matches in Rust is that they are exhaustive. What I mean by that is that we must exhaust every possibility in order for the code to be valid. So, for example, if in our code here we are gonna comment this arm, the compiler will actually not compile the program. It gives us an error because we are not exhaust every single possibility. Okay, guys, so watch out for that. So, if you wondered why in the first case I've used enums, it's because matches are exhaustive, so you can understand why. This means that the arms pattern must cover all possibilities, and if you use an enum, you simply have all the possibilities right in the enum. So that's why. And one other thing that I think is really neat about match is that differently from using if-else blocks, in match the expression don't have to evaluate to a Boolean value. An expression can be of any type. So I think that's pretty cool. A classic use case of match is when you want to match an option type. So for what I mean by that is that you can match a value, which is an option, and if the value actually contains some things, so if it's a sum, you execute some code, while if it's actually none, so it does not contain any value, you execute other code. So this is a simple way to manage option types. So, of course, we can relate this to our Pokemon game because we can create a function called useBerry, and useBerry takes an option of string as a parameter which will represent our berry that we want to use, and then we have a match. So if we don't have a berry, so if our bag is empty and actually berry is known, we print there are no berries left. Otherwise, if berry actually contains something, we can give this berry to our Pokemon and we're gonna print out using berry on our Pokemon. So here in our main block, we could have something like this. So we have the two versions of useBerry. So if we give an actual berry to our Pokemon, let's say an orange berry, the program will print out using orange berry on your Pokemon. Otherwise, if we don't have any berries, we just pass an on. So, as I said before, match arms are exhaustive, so they must exhaust all possibilities. And this is why I've used enums, because it's easy to exhaust every possibility if you use enums. But sometimes there are cases in which we can also take special actions for a few particular values, but for all other values, take one default action. So, for example, if we know that our Pokemon can have a stat, so it can be without any affections, it can be frozen, sleepy, paralyzed, and so on. So we're gonna represent this with another enum. So we have an enum PokeStat, which has values active, frozen, paralyzed, or sleepy. And then we're gonna implement a method which will be called executeMove. So if our Pokemon is in a state that allows him to execute a move, he's gonna execute it, otherwise he's not. So let's delete this. So executeMove here, it has the same signature as the other method, and it takes a match when if our move corresponds to the active enum, we print executeMove. Otherwise, this is the catch-all. This underscore is called the catch-all pattern, so it exhausts every other possibility. We are just gonna print out Pokemon cannot attack. And here we are just making things easy because Actually, in the Pokemon game, it's not just like that, but we're gonna pretend that it's just like this. So, as I said, this is the catch-all pattern, so this means any other possibility. And pay attention, guys, because as I've said previously, the compiler will evaluate each arm in order, so from the top to the bottom. So first, it's gonna compare the move with the active value, and then the catch-all pattern. But, of course, if you switch this, so if you put this on top of active, what do you think will happen? The compiler will execute always this first arm because it's a catch-all. So whatever value you put inside the function, this pattern will match. So this is why you have to put it in the end. Okay, guys? So let's say now that in the case that the Pokemon is unable to attack, we just simply do nothing. So we can substitute this expression with an empty expression. This is an empty tuple, which is common in Rust, so this means that in all the other cases, simply do nothing. Okay? As you can see here, this is actually useless code that we have to write, because it's simply sugar syntax for say, just do nothing. So it would be nice to express this behavior in a more concise way. And this is what the if-let statement does. So let's look at this. So instead of match, we can use the if-let statement that works just like this. So this is similar to an if block, because here we have if, and then we destructure a pattern. So we're gonna say if the stat variable, which we are gonna assign now with the let keyword, is equal to the PokéStat active, then we execute a move. If this condition does not pass, we are not gonna execute the code inside this block. And here we don't have an else, so it's equal to doing this. So it's obvious that if PokéStat is not active, so whether it's frozen, paralyzed, or sleepy, we don't have any other blocks to conditionally execute, so the program will simply does nothing. Okay, guys? Of course, you can mix this up. You can add an else block. So in all other cases, and this is similar to use the underscore, you can just put whatever code you want. So in this case, it's similar to the match pattern of before, where we have if it contains some value, execute move, otherwise execute other code. But because we want to do nothing here, we just left it like this. So the if-let statement reduces the lines of code that we have to write. And also, I think that's really useful because someone who's reading our code can understand immediately that execute move is a special event that just occurs when the Pokemon is active, while in the match pattern you had to examine all the arms to realize that. So if-let means less typing, less indentation, and less boilerplate code. However, you lose the exhaustive checking that match enforces. So I think that choosing between match and if-let really depends on what you are doing in your particular situation and whether gaining conciseness is an appropriate trade-off for losing exhaustive checking. So in other words, you can think of if-let as syntax sugar for a match that runs code when the value matches one pattern and then ignores all other values. So guys, there's really not much left to say. I hope that you enjoyed this video, and I have a free Rust cheat sheet that you can download. The link is down in the video description. And what else? I want to grow this Rustacean community as large as possible, so spread the word by liking and subscribing. And of course, just leave a comment if you want other videos about other topics. And that's it for today. Happy coding!